use ASLR, even though they haven't been compiled with the dynamic base linker flag and stuff like that. As I said, not very interesting to most application developers because it actually requires you to convince your customers to install this software, because it is a software package that you install in Windows that applies all these extra mitigation routines. Emmet is actually coming out with a new release, later in August. So check it out then. It will have several more anti-exploitation techniques that will break existing standard shell code, for example. Won't work anymore. It has to be rewritten. So a lot of old exploits and stuff like Metasploit won't work anymore, which is quite interesting. Those are the URLs you should check out. You can Google Emmet and Microsoft, and you'll probably get those same URLs. Actually, that's how I got them. But there's a training video there that the developer guys explain how it works. And there's also the download link on the bottom. Before I got into that brief digression, I was talking about modularizing your application. And that's one thing that I think is really important for people to understand, is that once your application grows from a simple tool into a full-fledged app, there's no way you're going to be able to look at it as a whole and understand all the interconnections between different parts of the code. So what you really need to do as an application developer is look at how can we break this down into different components, different parts that we can look at in isolation. So if we can take our application and break it down into several different parts and specify in documentation all the interactions between that module and the rest of the application, then we can actually start to look at that particular module in isolation, look at those interfaces, and do threat modeling, perhaps according to the SDL by Microsoft, or in another style that you're more comfortable with. But at least looking at these in bite-sized chunks that you can understand what the code is doing with the inputs and outputs. And another thing that you can do when we're talking about application boundaries, of course, boundaries between different modules in the code, but also boundaries between the application and the OS. You can start to look at in every case where we create a system resource, for example, if we create a file, if we create a pipe, if we create something as simple as an event flag or something like that, that we apply a safe default DACL on that object, so that we're not creating, for example, a semaphore that's wide open for anybody to gain access to and start flipping around and potentially harming or potentially changing the execution flow of our application. This is especially important if you've got kernel code in your application. If you've got code in userland that needs to communicate with the kernel component using, for example, what's called a named driver entry or something like that. It's very important to make sure that you've got safe DACLs on the kernel component, so that somebody else can't go in and start talking directly to your kernel code, because that opens up a lot of attack surface that you don't want to be exposing. Right. So when you've once you've componentized your code, or broken it down into different components that are manageable, then you can also start to look at which of these components are actually possible to run with lower privileges, for example. Can I take, for example, this file format parser and break it off, spawn it off into a different process, because I've got easy input and output from it. I've got an input of a file or file handle or a file path to it, and I've got an output of a parsed data structure. That's pretty easy for me to partition off and compartmentalize, so that that code, which might be doing some hairy stuff, parsers always are difficult, can I run that in a lower integrity level process with a restricted token and all of these mitigations that we've talked about, or security features as I call them. If you're going this route and sandboxing stuff, check out the blog series by David LeBlanc from 2007 called Practical Windows Sandboxing. That's kind of the it documents how they kind of went about developing their own sandboxing techniques for Office, and it's kind of the start of, or rather Adobe has built on that work with the new Adobe Reader 10.0. So have a look at that, because it does bring up some important points that you need to be aware of when sandboxing low privileged processes. Also, when you're looking at these components, make sure that these interfaces, this should actually be a part of your threat modeling if you haven't already done it. Make sure that they're simple and clear, that they're non-ambiguous, that you understand the inputs and outputs and how that relates to other components in the system. And apply the principle of least privileges. If these components don't actually need access to system resources, then that code doesn't actually have to be running as a standard user. And if these components are too complex or require too many privileges, you should perhaps look at refactoring them and changing them and making the interfaces cleaner and simpler to make it easier for you to understand the implications and do threat modeling and stuff like that. In a perfect world, basically only the UI layer of your application would need to run with a full privilege set of the user, and perhaps not even that. That's not going to happen for most application developers, but you should at least strive to look at componentalizing and compartmentalizing those components within your application to make sure that you're using all of these features that you can be using in Windows to make it harder to attack your application. And basically, a lot of these features can be bypassed. I talked about /GS being easy to bypass if you're using an older version, for example, if you're using Visual Studio 2003 still. And what I want to convey to you is that doesn't matter to you. If you can use enough of these mitigation techniques and security features, then they will overlap to such a degree that it will make it significantly harder for somebody to exploit a vulnerability in your software, that you will have won so much by just doing these simple steps. There are no silver bullets to application security, but if we can just raise the bar enough that an attacker would either go after some other company or if we can raise the bar to such a degree that it's making the attacker invest a lot of time, effort, and money into making the exploit for a particular vulnerability, we will have protected our customers that much more. So we need to build securities in security as overlapping layers. So even if one of these layers isn't perfect, there will be another one underneath and another one. And hopefully either an attacker won't get through, or all of them, or it will be at least very costly for them to do so. Look at each component in isolation. Make sure that it's responsible for upholding the security of itself by verifying its inputs and making sure it produces safe output as well. Assume nothing but validate everything. So it's better to have several components within your application actually verifying the same data several times over than just verifying, hoping you've verified everything when you've read it from disk, for example, and then just trusting the data from there on in the application. So make sure that each component that you isolated, and when you're doing the threat modeling, make sure that it doesn't assume anything of its input, that it validates everything before it uses it. So to summarize a bit, build security in your applications by piling on everything that you can of this that we talked about. All the exploit mitigations that you can enable, please enable them on all operating system levels that support them. All of the toolchain features that you can use, please make sure that they are enabled. And it can be hard because sometimes you have to depend on third-party libraries that, for example, aren't DEP aware or don't support ASLR. But if you've got a lot of problems with that and you can't address it by demanding from your third-party software vendor to fix it, look at, for example, Emmet or something else as a workaround. Architecture in components. Make sure that your application isn't a monolithic application, but actually does make sense when it's broken down into separate pieces that might even be developed by different teams internally. And review them in isolation to make sure that they actually do what they're supposed to do, that they can stand on their own when confronted with arbitrary inputs and stuff like that. And once you've done that, try to partition your application and put components that don't need privileges into a separate sandbox process or something like that. And use the other Windows features to raise the bar for the attacker. So if you're sandboxing something off into another process, don't just put a restricted token on it and hope for the best. Learn from Microsoft. Check out the Practical Windows Sandboxing article series and pile on all of these features to make sure that the sandbox is tight. Look at, for example, the Google Chrome sandbox that they use. They've done exactly that. They've tried to use all of these Windows technologies to sandbox off all of the rendering and HTML processing in the browser into a separate process. And also look at the Microsoft SDL. There's a document, and I'm not sure if I'm getting the name correct, but I think it's referred to as a simplified SDL. And you shouldn't be confused by the name. It's basically the SDL process documents that have been stripped from everything Microsoft specific and specifically made to be able to, for you as an application development team, to adopt basically straight off because all the Microsoft specific parts have been edited out. So look at that and adopt the parts at least that make sense to you. Any questions? Anything? Yeah?
So you just went over in detail a lot of security measures that are available. I mean, the obvious question, if I don't mind drawing for that, is why are we still seeing so many problems within Windows? Are people not using it, or are the issues that we're seeing?
Yeah, so just to repeat the question for the camera. If we've got all of these lovely exploitation mitigation features and everything in Windows in the toolchain, why are we still seeing so many attacks against Windows applications? Well, if you look at Microsoft and their applications and Windows in general, which is a large code base, they've done pretty well recently.